Welcome back to the Deep Dive. We're the place you come to when you want to cut through all that noise and just get to the really important stuff.
And today, we've got something pretty staggering to look at.
Yeah, we're diving into some, frankly, unsettling research about Svalbard. Specifically, its record-breaking glacier melt during the summer of 2024.
It really is remarkable. This isn't just some remote event, it feels like.
Yeah.
Well, like a critical preview.
Definitely. And the headline fact is just mind-boggling. Get this. Svalbard, which is, a relatively small Arctic archipelago.
Tiny compared to the big players.
It lost something like 61.7 gigatons of ice just in that one summer.
An astounding number. And what's really shocking is how that stacks up globally.
Okay, yeah, let's pause there.
Yeah.
61.7 gigatons. It sounds enormous, but can you help us visualize that, put it in perspective?
Right. So a gigaton, it's a billion metric tons. Think maybe 10,000 aircraft carriers or 100 Great Pyramids. Now times that by over 60.
Okay, huge.
But here's the kicker. In that same period, the entire Greenland ice sheet, the massive one, lost about 55 gigatons.
Wait, Greenland, which is what, 50 times bigger than Svalbard in area?
Roughly, yes. 50 times larger.
And Svalbard lost more ice.
More ice from a much smaller area. That single summer melt from Svalbard alone added about 0.16 millimeters to global sea levels.
Okay, so our mission for this deep dive is clear then. We need to understand how this happened, what drove such an extreme event.
And crucially, why the single summer might be giving us a real concerning glimpse into the future.
So how did such a small place lose so much ice, so disproportionately? What does the research say?
It points very clearly to a specific and very persistent atmospheric circulation pattern. Basically, weather systems parked themselves in a way that just funneled warm air over the region.
Leading to record temperatures.
Record high air temperatures, yes. And not just warm, but anomalously warm. We're talking up to 4 standard deviations above previous observations in some periods.
4 standard deviations. For those of us not deep in stats, what does that mean practically?
It means it's extraordinarily rare, like statistically, under the climate conditions we should be in now, an event like this. You wouldn't expect it to happen more than maybe once in many, many thousands of years.
Wow.
And most of this record melting actually happened in a really concentrated blast. About 6 weeks.
Just 6 weeks for most of it. Okay.
Right.
So there's this rare atmospheric setup, but why Svalbard? Is it particularly vulnerable?
Yes. That's a key point. Svalbard is already known to be in a hotspot of Arctic amplification. It's warming faster than the already rapid warming across the rest of the Arctic.
Right.
And during that summer, the August air temperature anomaly was, get this, 3.7 degrees Celsius higher than the 1991 to 2020 average. That's a huge jump.
And what caused that specific jump? Just the air patterns?
That was the main driver, warm, moist air coming up from the south. But crucially, it was massively amplified by something else, a marine heat wave in the Barents Sea.
The Barents Sea, that's the water just to the east and northeast, right?
Exactly, a really important gateway for Arctic Ocean currents. And that sea itself was incredibly warm. Surface temperatures soared 3.5 to 5 degrees Celsius above the baseline.
So you had warm air arriving, and then it picked up even more heat and moisture from an already superheated ocean nearby.
Precisely. It was like a perfect storm for melting glaciers. The arriving warmth got an extra boost right on Svalbard's doorstep.
So the study makes it clear summer melt is tightly linked to air temperature there. But what does this tell us going forward? Was 2024 just a statistical fluke, a really bad one-off?
Well, yes and no. It was statistically rare for today's climate, but the climate projections, honestly, they're quite sobering.
How so?
They strongly suggest that these kinds of temperatures and therefore these kinds of extreme melt events are going to become, well, increasingly common.
Even if we manage to curb emissions significantly.
Even in the most optimistic scenarios scientists model, like the SSP-126 low-emission pathway. The projections show that by the end of this century, the average summer temperature for Svalbard could look a lot like the extreme we saw in 2024.
Wait, the average summer could be like that record-breaking 4 standard deviation summer?
That's what the models are indicating. It means roughly half of future summers, even under that best-case climate scenario, could actually be warmer than 2024 was.
So 2024 wasn't just an anomaly.
It's described quite starkly in the research, a window into Arctic glacier meltdown in a warmer future.
A window. Or maybe even a forecast.
Exactly. A forecast for conditions perhaps 70 years ahead of schedule, you could say. The extreme is becoming the baseline.
So the big takeaway, the thing for all of us to really grapple with, is that this wasn't just a bad summer. It was potentially our future, served up decades early. What was shocking in 2024 could be normal, even with our best efforts.
It really forces you to think, doesn't it? If an event that should be incredibly rare, statistically almost impossible today, can become the norm within our lifetimes. Yeah.
What other extreme weather events that seem statistically rare right now are also lining up to become the new standard? What does that truly imply for, global systems, for communities way beyond the Arctic?
That's the unsettling question, isn't it? What other signals are out there that we might be dismissing as rare today, but are actually previews of tomorrow? Something to really mull over.